Hello everyone. Welcome to today's presentation. I'm excited to guide you through our journey titled Mastering Computer Science. This is a practical journey designed specifically for Class 11 students. Throughout this session, we will explore key concepts, skills, and tips to help you succeed in computer science. So, let's get started and dive into this fascinating subject together. Now, let's explore some fundamental concepts that form the backbone of programming and computer science. First up, persistent storage and file handling techniques. This is all about how we save and retrieve data, making sure our programs can remember information even after they shut down. Next, guiding the flow of our programs with loops. These are essential for repeating tasks efficiently without rewriting code over and over. Organizing data is also crucial, and that's where lists, tuples, and dictionaries come in. They help us manage and structure information in a way that's logical and easy to access. Interacting with our code involves input and output operations, as well as basic arithmetic, which allows us to communicate with users and perform calculations. Understanding your machine is another key aspect. Knowing system information helps us optimize and troubleshoot our programs. Building blocks like functions and string manipulation are tools that enhance code reusability and make our programs more flexible. Moving beyond just coding, developing essential IT and software skills prepares us for real-world problem-solving. Python programming serves as a gateway to understanding logic and algorithms. It's a versatile language that makes complex concepts more approachable. Decision-making with conditionals allows our programs to respond dynamically, making them smarter and more adaptable. And finally, all of these elements come together in the broader context of computer science, the foundation that supports everything we do in technology. Let's embark on a comprehensive exploration of computer science, specifically tailored for Class 11 students. In this part of our presentation, we'll focus on introducing the fundamental concepts of computer science. I'll explain key points thoroughly, but in a conversational way, highlighting what's most important. We'll see how these ideas connect to the overall theme of understanding and working with technology. Think of this as laying the foundation for your future in the tech world, where you'll learn about programming, data structures, and essential IT software skills. These basics are crucial because they set the stage for all the advanced topics you'll encounter later. So, as we go along, keep in mind that mastering these fundamentals will help you build a strong and confident approach to technology and problem-solving. Let's start our journey with Python, a language that's both versatile and friendly for beginners. It's a great choice because it allows new programmers to get up and running quickly without feeling overwhelmed. In this section, we'll focus on the core concepts that serve as the foundation of any programming language. These are the building blocks that help you turn ideas into working code. By mastering these, you'll develop essential logical and algorithmic thinking skills, which are crucial for solving problems efficiently. Remember, learning Python not only helps you understand programming basics, but also opens the door to more advanced topics later on. So, as we go through this section, keep in mind how these concepts connect to the overall theme of becoming a confident coder. Let's talk about how modularizing our code can really boost both efficiency and reusability. When we break our program into smaller, manageable pieces, it becomes much easier to understand, test, and maintain. One key concept here is functions. Think of functions as mini programs within your main program. They perform specific tasks like performing calculations or handling data manipulations. By using functions, we avoid repeating ourselves and make our code cleaner. Next, we have arithmetic operations. These are the fundamental building blocks of many programs. They handle calculations and numerical manipulations. Mastering these allows us to perform a wide variety of tasks, from simple addition to complex mathematical modeling. Then we come to control structures, which guide the flow of our program. Loops and conditionals help us make decisions and repeat actions efficiently. They ensure our programs respond correctly to different situations and inputs. Finally, understanding input and output is essential because it's how our programs interact with users. Whether it's reading data from a user or displaying results back, Input-output makes our programs dynamic and user-friendly. All of these key concepts, functions, arithmetic operations, control structures, and input-output, are fundamental to building effective, reusable code. They tie back to our overall goal of writing better, more efficient programs that are easier to manage and adapt over time. Now, let's look at how we can craft clear output for users. At the core of any program is its ability to communicate effectively. Students will learn how to display messages to the user and also how to receive input, which is essential for creating interactive applications. This forms a foundational skill, enabling us to build programs that can interact with people in a meaningful way. Alongside this, we'll also master basic arithmetic operations. These are the building blocks for many calculations, whether we're working with simple addition or more complex financial computations. By applying these operations to real-world scenarios, you'll see how programming can solve practical problems. So, in this part of the course, we'll focus on the basics of interacting with code, how to input data, output messages, and perform fundamental calculations, all of which are crucial skills for any aspiring programmer. Now, let's explore how loops are essential for automating repetitive tasks and processing data efficiently. In this slide, we see that students will gain proficiency in both for and while loops, which are fundamental programming constructs. Understanding when to apply each type of loop helps in designing optimal programs. For example, using a for loop is great when the number of iterations is known beforehand, like printing a pattern or generating a multiplication table. On the other hand, while loops are useful when the number of iterations depends on a condition that may change during execution, such as summing a sequence until a certain limit. By mastering both, students can write more flexible and efficient code. This ties into the overall theme of the presentation, emphasizing how control structures enable us to automate tasks and handle data systematically. Now, let's explore how conditional logic helps us assign grades based on marks. This is a great example of how programs can make decisions. By checking if a score falls within a certain range, we can assign the appropriate grade. Next, we'll look at how programs identify special numbers like Armstrong numbers and perfect numbers. These involve specific mathematical properties that we can verify through conditional statements. We'll also examine how to determine if a word or phrase is a palindrome, which means it reads the same forward and backward. This is another instance where conditional logic helps us test and confirm certain conditions. Moving on, we'll discuss string symmetry, which involves checking if strings are symmetrical in structure or characters, again, using conditional checks. In the realm of special numbers, we'll see how to verify if a number is prime or composite. These checks are fundamental for many mathematical and cryptographic applications. All of these examples highlight how conditional statements empower our programs to make intelligent decisions based on specific criteria. This leads to more dynamic and responsive applications. Finally, as we wrap up, remember that mastering if-else constructs allows us to create logical checks that make our programs smarter and more adaptable. This is a core skill for building effective decision-making capabilities in software. Now, moving on to slide 9, let's focus on the building blocks that make programming more efficient and manageable. At the core, we have functions. They are incredibly important because they help us write clean, modular, and reusable code. Instead of rewriting the same code multiple times, we can just call a function whenever we need it. This saves time and reduces errors. Another key aspect here is string manipulation. Strings are textual data, and knowing how to work with them is essential for many applications. Techniques like converting text between uppercase and lowercase, counting vowels and consonants, or checking if a word is a palindrome are common tasks. These skills are vital for processing textual data effectively. Connecting these ideas to our overall theme, handling data efficiently, functions and string manipulation are the building blocks that empower us to write flexible, powerful programs. They help us perform complex operations with simple, reusable tools, making our code more robust and adaptable. Now, let's talk about dictionaries, which are key-value pairs that make data retrieval really efficient. They're especially useful when managing student records or identifying top scorers quickly. Dictionaries allow us to access data directly through keys, making the process fast and straightforward. Moving on to lists, these are dynamic, ordered collections that let us add, remove, or change items as needed. They're great for situations where you need to find the largest or smallest elements, swap items, or search through data efficiently. Lists are very flexible and widely used in programming. Then we have tuples. These are similar to lists in that they are ordered sequences, but they are immutable, meaning once created, you can't change them. This makes tuples perfect for storing fixed data that shouldn't be altered, like constants or configuration settings. Overall, understanding these data structures, lists, tuples, and dictionaries, is essential because they help us organize and manage data effectively in our programs. Whether we're storing student information, tracking scores, or handling fixed data, choosing the right structure makes our code more efficient and easier to maintain. Now, let's talk about creating, reading, updating, and deleting records, such as student data. These operations are fundamental for managing data efficiently in many applications. For example, you might create a new student record, read existing data to view or process it, update information when needed, or delete records that are no longer relevant. Moving on to binary file management, this involves reading and writing data in a format that's not human-readable, but is efficient for computers. It's especially useful when dealing with complex data structures or large amounts of data, as it allows faster access and saves space. Next, we have text file operations, which include tasks like reading and writing lines, or even counting words or vowels within a file. These are common tasks that help us manipulate and analyze text data easily. Finally, it's important to understand that programs often need to store and retrieve data persistently. That's where file handling techniques come into play. They enable us to save data beyond the runtime of the program, making our applications more useful and reliable in real-world scenarios. This section is about introducing you to these essential skills, so you can confidently work with both text and binary files in your projects. Beyond programming, having a strong understanding of common software applications is absolutely essential. It's not just about coding. Being proficient with tools like the MS Office suite is critical for both academic and professional success. These applications, Word, Excel, PowerPoint, are the backbone of most tasks you'll encounter. Mastering them allows you to communicate ideas clearly, analyze data effectively, and present information confidently. Additionally, understanding computer hardware is equally important. Knowing how computers work under the hood can help you troubleshoot issues and optimize your workflow. So, in this module, we're emphasizing practical skills that complement your technical knowledge. Developing these software skills will empower you to be more efficient and effective in any environment you find yourself in, reinforcing the overall theme that a well-rounded IT skill set is indispensable in today's digital world. So, in this final part, I want to emphasize the importance of communicating complex ideas clearly and visually. Effective presentations are all about making intricate topics like AI and data mining accessible and engaging. This means designing slides that are not just informative, but also visually appealing, helping your audience grasp difficult concepts easily. We use tools like MS PowerPoint to create these engaging slides, incorporating visuals, diagrams, and concise points that highlight the key messages. When presenting advanced topics, it's crucial to simplify information without losing its essence, ensuring your audience stays interested and understands the core ideas. Moving on, MS Excel plays a vital role in creating mark sheets, generating charts, and performing data analysis. These functions help you present data in a way that's easy to interpret, supporting your narrative with clear visualizations. And of course, MS Word is essential for preparing professional biodata and formatting documents. ensuring your reports and documents look polished and consistent. Altogether, mastering these tools and techniques enables you to communicate your ideas effectively, no matter how complex the subject. This ties back to our overall goal of enhancing your presentation skills to convey technical information confidently and clearly. Now, let's talk about understanding your machine by examining system information. First, documenting the operating system, installed applications, and their versions is crucial. This helps us keep track of the software environment we're working with. Next, we look into the hardware configuration by checking details like the CPU, RAM, storage devices, and other components. Having a clear picture of both the software and hardware setup is essential. A well-rounded computer science education includes this knowledge because it allows us to understand what makes our programs run smoothly. Ultimately, being familiar with these details enables us to troubleshoot effectively, optimize performance, and better understand the systems we develop and work with. This final practical skill ties everything together, giving us a comprehensive view of the computer's inner workings.